So in this series of Snap Circuits videos, we're going to look at Project 409, the Transistor Tester, up to Project 430, the Machine Gun Recorder. So Project 409 is our Transistor Tester. There it is in the book, and there it is on the board. And so we have our 3-volt supply, which is again using our little battery eliminator. And we're using our NPN transistor because it's a transistor tester. So the power switch is the on-off that's feeding our transistor, and then our activation for it is through our press switch going through our R3 5.1K resistor, and then we've got another 10,000 ohm resistor going through our meter, which will allow us to see the current through it. So when we turn the slide switch on, nothing happens obviously because the NPN transistor is not turned on, so no current is flowing. But when we press our press switch, our meter deflects all the way over to 10, showing 10 milliamps, because our transistor is now being energized through the base of it, allowing current to now flow through the collector and emitter, completing our circuit, and then we can see we got 10 milliamps of current flowing through it. Release the press switch while our NPN transistor is no longer energized, and because of that, we no longer have any current flowing through there, and our current deflects back to 0 on the meter. And again, they call this project the Transistor Tester because if the meter was deflecting less than 10 milliamps, that would tell us that something is going on with the transistor, whether it's a little burned out or failed entirely if the meter didn't deflect at all. Or it could even tell us that something is off with the resistors if the current is swayed off for some reason. But since this is going to the full 10 milliamps, we know that both our resistors and our NPN transistor is good. So that is Project 409. So now we're going to move on to Project 410, which is the adjustable voltage divider. So here we have Project 410, which is the adjustable voltage divider. Here it is in the book, and there it is on the board. And it's a similar configuration to the last project, but we got rid of our NPN transistor and now replaced it basically with our variable resistor now and just our 10,000 ohm resistor across our meter there. So we start out with our variable resistor deflected all the way to the right here. And when we turn the circuit on, our meter deflects all the way over to 10 milliamps because our current is flowing through our variable resistor from the positive input here, through our meter, and then through our 10,000 ohm resistor, and then back to ground. Now as we shift the variable resistance to the left, our meter begins deflecting less and less, because less current is going through there. And when we get to about this point, we get about 5 milliamps. So now we've roughly got an equal distribution of current flowing through the meter, but also just flowing straight through the variable resistor through our other loop here back to ground. And of course, if we deflect it all the way to the left, well, now all the current is going through this loop, and none of it is going through our meter and 10,000 ohm resistor. So by varying the variable resistor here, we can control the division of voltage across these two loops here. And so we can see that on our meter as we change the resistance on our variable resistor here. So that is how project number 410 works. So now we're going to move on to projects 411 through 418, which is our automatic display, starting with the capital letter C. So here we are with project number 411, the automatic display, capital letter C. There it is in the book, and here it is on the board. So we've got our 7-segment LED display out again, running off of 3 volts, being limited by our 100 ohm resistor, our slide switch to turn the whole circuit on and off, and our 7-segment LED is being driven by our alarm IC, which is both driving our whistle chip as well. So as the alarm IC turns on and off, we'll hear it buzzing through the whistle chip, but also its output will be turning on and off whatever segments of the 7-segment LED we have. So in this configuration right now, we've got it set up so that it displays the letter C because we're lighting up segments D, E, F, and A. So pretty much the top segment, the bottom segment, and the 2 side segments. So when we turn the switch on, it flashes the capital letter C, And I don't know how well the camera's picking it up, but the whistle chip is also producing the sounds from the alarm IC. So that's how Project 411 works with the capital letter C. So with Project 412, we're now going to display the capital letter E. So for that, we're just going to take a number 2 and we're going to connect it to G, so that we light up our center segment. And when we turn it on now it's flashing the capital letter E on our 7-segment display. So that's Project 412. Now Project 413, we're going to display the capital letter F. So for that, I'm going to pull stuff off so I can just see where everything goes. Make sure that this one snap stays here since we don't have a flap there. So we're going to connect A, E, F, and G. So we got A, E, F, and G. So basically we were just taking the D out of there, we turn it on, and now you get the capital letter F, because we no longer have the bottom segment lit. So that's Project 413. Now Project 414, we're displaying the capital letter H. So we're going to connect B, C, E, F, and G. So we're going to take A off of here, and leave G there. Let's see, B, C, E, F, G. So we turn it on, now we get the capital letter H flashing. So that's Project 414. Now Project 415, we're going to display the capital letter P. So for that we connect A, B, E, F, and G. So we're going to keep F there. Let me disconnect C, move this to A. We got B connected, E connected, F, G. So we turn it on now, and we get the capital letter P flashing on the display. And again, the whole time we're still getting the buzzing sound coming from our whistle chip again, because our alarm IC is driving both of these. So that's Project 415. Now Project 416, we're going to display the capital letter S. So we're going to connect A, F, G, C, and D. So we have A there, we have F there, G there, C, and D. So I'm going to move this here, and I'm going to move this here. Turn the circuit on now. And it now flashes the capital letter S. Of course, in other projects, this is also represented as the number 5, but it's calling it a capital letter S here. So that's Project 416. Now Project 417, we're going to have the display of the capital letter U. So for that, we're going to connect B, C, D, E, and F. So we don't need A any longer. We're going to reconnect B. We have C connected. We have D connected. We don't have E connected. So we're going to connect it there. And then F. So we turn the circuit on. And now we get the flashing capital U. So that's Project 417. Now Project 418, we're going to display a capital letter L. So for that case, we're going to connect D, E, and F. So we're only connecting 3 points. So D, E, F, don't need these. Turn the circuit on. And now it's flashing a capital L on the 7-segment display. So that's Project 418. So now we're going to move on to Project 419, which is the whistle chip sounds. So here we are with project 419, the whistle chip sounds. There it is in the book, and here it is on the board. So like previous circuits, we've got ourselves kind of an oscillating circuit setup here using multiple capacitors and resistors coupled with our NPN transistor, which is then feeding our transformer. And the transformer is set up so that it's stepping down, because you see we have the multiple windings on this side going to less windings on the other side, so we're stepping the voltage and current voltage down, increasing the current, and that's feeding our whistle chip at the end here. So when we turn the circuit on, it takes a moment, but then the circuit begins oscillating, which then feeds our transformer, which then of course comes to our whistle chip when we get the output. However, the whistle chip is very quiet, even though it is oscillating and producing output. Let me see if I bring the camera in and see if we can pick up that sound. So the whistle chip is oscillating, and it is producing a tone, but again, it's very quiet. It's very low amplitude. And the camera's pretty close there, and I'm hoping that it's picking it up. Turn it off. Turn it back on. So again, hopefully that sound is coming through because it's very low in amplitude, but the circuit is oscillating. Come back up here. Get into the right spot on the tripod. So that's project 419. Now project 420, we're going to move stuff around. Get the power cable out of the way here. So with project 420, we're now going to take the whistle chip off of there, and we're going to connect it across these 2 points, across C1 and our 3 snap here. We're just going to leave our transformer freestanding there, and now when we turn the circuit on, see the whistle chip is producing a slightly lower tone than it was off of the transformer because it's not oscillating as quick from that point. So we get a lower tone, but you can tell that we have more amplitude because the whistle chip is more audible on that position. So that's project 420. Now project 421, we're going to connect the whistle chip across a different set of points. So now instead of connecting across here, we're going to connect it straight across capacitor C1. So I'm going to take a 1 snap here so that it sits level. Now we'll turn the circuit on again. And that way bring the camera in a little more since it's not as audible as before. So you hear that the whistle chip is producing a pulsing sound, and that's because capacitor C1 is charging and discharging there as it flows through the base of the NPN transistor there. So the circuit is oscillating again, but it's also, from that point it's oscillating a lot slower, to the point of where it's just pulsing the output. So that's project 421. So project 422, we're now going to go back to where we were before. Let me put this back on the end of our transformer. But we're going to take our C4 capacitor out here, and we're going to replace it for the 10 microfarad. So instead of 100 microfarads, we're going to have 10 microfarads there. Same orientation too, because they are polarized. So put that there. Couple that there. Here. Here. And here. Alright. So now we get it configured and turn the circuit on this time. And again, the circuit is oscillating, but it's incredibly low amplitude on the end of the transformer there, so that we bring the camera in. Again, I hope the camera is picking it up because, again, it is oscillating, but it is incredibly low amplitude coming out of the whistle chip there to be able to hear it through the camera. So that is project 422. Now project 423, we're now going to change that capacitor around again with an even higher capacitance capacitor, our 470 microfarads. So we've got to disconnect this again. Get out of there, take this out, put this in, so now we got even more capacitance in the circuit. Put it all back together. And now we get it configured with 470 microfarads of capacitance there. Now we just check it on this time. It takes a little bit longer for that capacitor to charge up before the circuit starts oscillating. Again, it is oscillating and producing a sound out of the whistle chip, so let me bring the camera back in. Again, low amplitude as before, but the tone is different because we have a much larger capacitor on the end there. And as I stated before, it does take a while for the circuit to charge that capacitor up before it starts oscillating. And you can probably tell if the camera's picking it up from the sound of the switch to the sound of the whistle chip. And now the circuit is now oscillating. So you can kind of hear that delay between when the switch is actuated to when the tone is being generated by the whistle chip to indicate how long it's taking that 470 microfarad capacitor to charge up before the circuit can start oscillating. So that is project number 423. So now for project 424, we're going to keep it like it is, but now we're going to put this 100 microfarad capacitor back here, and we're going to connect the whistle chip across points B and C, which is across capacitor C1 and R3 here, and also across C1 entirely itself, so that we put the 100 microfarad capacitor back on here, and there goes the part flying. So there goes our 100 microfarad capacitor back on. Get our resistor. Make sure I'm putting the right one back on because there's another one over there. And I'm missing one step. Oh, that's because it's right here. We'll need that in a minute anyway. So we get that configured. Now we're going to take the whistle chip off of here, and we're going to place it across this point first and turn the circuit on. So the circuit is again oscillating, and compared to, let's see, where did we have it? Compared to project 420, the circuit is oscillating at a lower tone now because again we have a larger capacitor in that slot. Because it was a 10 microfarad capacitor for project 420, for project 424 it's 100 microfarads now. So we've increased the capacitance by a factor of 10. So the result is we get a lower tone being generated from our whistle chip. And we can put it directly across capacitor C1 and see how it affects that compared to project 421 that we did earlier. So it's still pulsing, and to me it almost sounds about the same as what project 421 was, even with that 100 microfarad cap there. that's project number 424. Now we're going to move on to project 425, which is LED music. So here we are with project number 425, the LED music. And there it is in the book, and here it is on the board. And you may notice something slightly I did different is they've got our third diode here set up using snap wires. Instead, I just directly hooked it up there, so I don't kind of see the need for that. But if you want to use the two snap wires to hook it up, you can do that. I just prefer this because it's much simpler. But anyway, we have our recording IC on here, and it's being driven via 6 volts. And because of our battery adapter, we're just using another 3 snap in its place. And it's driving the base of our NPN transistor off its output, which is connected to both our green and red LEDs. So when the recording IC is generating output, it turns our NPN transistor on, which of course is going to turn our green and red LEDs on. And our press switch is being used to activate the built-in songs that are on the recording IC, because it's got 3 songs built in on the integrated circuit on there. So we press the press switch, it starts playing the first song there, and our output from that is being represented by, again, the 2 LEDs, the green and the red, being turned on because it's powering our NPN transistor by feeding the base of it from its output. And as the song plays, as long as it does that, it will have the LEDs on. Now, when the song stops playing, we'll see the LEDs go out. The purpose of our D3 diode here is just for reverse polarity protection on the recording IC so that current does not try to flow back the other way through it. So you see that the song finished and our LEDs went out. Press the press switch again, it will now play the second song. And because the songs have different lengths of how long they play for, the LEDs will stay on for different rates of time. So we'll see how long that the red and green LEDs stay on for the second song here. Now again, we don't have a speaker or whistle chip hooked up, see our LEDs went out again, so we can't hear the output. We're only seeing the output visually with the LEDs. So now the recording IC is playing the third song, and when it's done playing the third song, your LEDs will again go out. It's no longer feeding the base of our NPN transistor. So the third song finished and the LEDs went out. So that's how Project 425 works. Now Project 426 is the light controlled LED time delay. So what we're going to do with that is, instead of using our press switch to control it, we are going to use the photoresistor, and we're going to let light control it. So I'm going to put this here. I'll just cover it with my finger so it doesn't allow any input. Plug it in. And when I let my finger off the photoresistor, see the LEDs come on because it's allowing a connection. But you see, I can control the recording IC by turning the LEDs on and off, by giving it an on and off signal to the input there. Because with the press switch, if I press it one time, it turns on the recording IC. If I were to press the press switch again while it's playing the song, it will stop the recording IC. So by waving your hand across it, you can turn the recording IC on and off, and thus turn the green and red LEDs on and off, because you're turning the output of the recording IC to the NPN transistor's base there on and off, so no current ends up flowing. So that's how project number 426 works. So project 427 is the touch-controlled LED time delay. So for that, instead of using our photoresistor, we're now going to use our PNP transistor to control it. So, put our PNP transistor there, we plug the circuit back in to power it. And now what we're simply going to do is just connect ground to the base of our PNP transistor there using our fingers to complete the circuit there. And because a transistor is basically listening on the base there for just a small amount of current to turn it on or off, when we touch those contacts, it's enough to turn the recording IC on. And I can turn it off, turn it on, turn it off, turn it on, turn it off. So just by touching those contacts, it allows me to turn the PNP transistor on and off, which in then turn turns the recording IC on or off, which then of course turns the NPN transistor on and off, which then allows us to see whether our red and green LEDs light up or not. So that's how project number 427 works. Now project 428 is the alarm recorder. So here we are with project number 428, the alarm recorder. There it is in the book, and here it is on the board. So we've got our recording IC again, being run off of 6 volts, but now our NPN transistor has our speaker across it, so we'll be able to hear its output, and we get our 6-volt lamp there to help limit the current going through our speaker. And our alarm IC is being fed, and its output goes into the input of our recording IC, so we're essentially recording the audio output from our alarm IC and storing it in the recording of the recording IC there. And so we have our press switch to control the playback, and then we have our slide switch to control the recording mode of the recording IC. So right now the alarm IC is technically active, but we can't hear it because the output is from our recording IC. So when I turn on the slide switch, we get our 1 beep there to indicate the recording IC is recording. It gives us those 2 beeps to indicate that it's finished. So we turn the slide switch off. And now when we press the press switch, we should get the audio from the recording IC played back through our speaker there that it took from the alarm IC, along with one of the built-in songs after a couple seconds. So we got our output from the recording IC that it took from the alarm IC there, and after the few seconds of that recording, it's now playing the built-in song. So we can do it again. And now it's playing the next built-in song on there. But it has the recording IC, has the alarm IC's output stored in it right now. So that's how project 428 works. Now project 429, we're simply going to remove this one snap from here. So we're going to change the alarm IC's output. So turn the slide switch on, let it record a new audio output from the alarm IC. Got that, and now let's play it back. And again, it sounds pretty similar to project 428 again. As in previous projects, I said this connection point on the alarm IC always acts a little strange. So that's how project 429 works. Now project 430, we're just going to take the snap, and instead we're going to put it on this point here. Let's make sure that that is correct. Yes, it is. So let's start the recording there. Got that saved, and let's play it back. And now it gives us the machine gun sound effect from the alarm IC. And again, that's stored in the recording IC. So again, our alarm IC is playing different sound effects, which is going into the input of our recording IC, and when we tell the recording IC to start recording, it takes that audio and saves it in the recording IC module, and then we can play it back using the press switch, which is feeding our NPN transistor so we can hear it through our speaker. So that's how project number 430 is, and that concludes this set of Snap Circuits videos.